So the basic idea of the chapter, I guess, is clear. Others haven't joined yet, no? Arhan, Ahmed, they haven't joined yet.
Yes, sir.
Okay, okay. Let them join. While they are joining, you try to answer this question.
Yes,
I'm
sir.
writing the value of masses of Earth and another figure. Do I need to tell what is the figure of, of which planet I'm referring to? The second one.
Yes.
Is that a Saturn or Uranus?
That's Saturn.
No, that is Uranus here.
But it
Okay.
has the circle thing, right?
Yeah, circles are there as well, but it's a Uranus here.
Oh,
Okay.
okay.
So the mass of Earth is 5970. Just look at the number of zeros. How many
Yes,
zeros
sir.
are here? That much of zeros, huh?
21. Yes.
Now look at the mass of Uranus. Somewhere that much of zeros. Getting?
Yes.
Okay. So looking at the mass of the two objects here, can you
Yes, sir.
say just by looking at here that which one has got more mass?
Uranus.
It is quite difficult. You
Yes.
can't be very sure. It looks like they have
Yes.
got
Yes.
Uranus has got more mass, but you can't be 100% sure. In order to do that, we have to calculate the number of zeros in that right now. Now, for example, take the distance of Saturn and Uranus from Sun. Okay, so Uranus, it is here Uranus. Let's say the distance between Uranus and Sun is this much meter. That is the distance between
Yes.
Uranus and Sun. Okay, and let's, if you were to look at the distance between Saturn and Sun, yeah, it is somewhat like this much.
What are you talking? I got disconnected.
Yeah, I was basically saying this. Now, if you were to look at the distance between Saturn and Sun, this is would be the value, approx value. The question
Yes.
what I'm trying to raise here, that is it convenient? Can you read these numbers? The question is, can you read these numbers properly?
No.
No. Obviously, we can read, but it is quite difficult now.
Yes.
That will take lots of time. Okay. So having a number like 1 and having this much of zeros, it is rather easier to read the number like 10 raised to the power 12 than to read it like this. Okay, just give me a minute. Yeah. So it is rather easier to read the numbers in the form of exponents when we raise the number to their powers, right? So here
Yes,
we
sir.
can say that 10 raised to the power 12 now,
Yes.
right? So that is basically the purpose of the chapter, exponents and power. Yes, Arhan, am I audible? Can you hear me?
Yes, sir.
Yeah, so we have just started the chapter. We have already covered the basics things, but few things we were visualizing here. Imagine you are so here you are having Earth and Uranus, and look at the given masses of the two planets, right? Look at the figure here. How many zeros are there in their mass? And then again look at another figure that is of the solar system. And the suppose the distance between Uranus and Sun, approx it is given this much. That is the distance between Uranus and Sun. And approximately this much is the distance between Saturn and Sun. Now, can we read these numbers very easily? These are
No.
quite big numbers right now.
Yes.
So numbers in this form, which are too large, right? We can rather shorten them in the form of their exponents and read them simply as 10 raised to the power 12, for example, in the case of this number. Getting it now?
Yes, sir.
So that is basically the purpose of the chapter, exponents and power, right? So the numbers which are very difficult to read, write, understand, or compare, to make these numbers easy to read, right, compare and understand, we use exponents, right? Let me write it
Yes.
over here. The numbers that are very difficult to read, write, understand, and compare, to make these numbers easy to read, easy to write, compare, and understand. And understand, we use exponents. Getting it now? So
Yes,
whatever
sir.
we are studying, we need
Yes,
to
sir.
study about its purpose as well, right? So you have bigger numbers. For example, let's take example another again, like this. We can shorten it and write write it like this, right? You have
Yes,
numbers
sir.
like, let's say, 1331, right? We can
Yes.
shorten it and write it like this: 11 raised to the power 3.
Yes, sir.
Getting it? Okay, or 125. It is quite easy to read this, but if you have bigger numbers, we can shorten it and write
Yes,
in
sir.
the form of exponents.
Yes, sir.
Okay, so now let's recall few of the things we have discussed in the previous class. In your previous classes, you guys have, I guess you guys have studied about some basics of exponents.
Yes,
Hmm?
sir.
Yes.
Okay, you guys already are having the idea from the chapter square and cube
Square
roots,
roots.
square roots and cube roots, right now.
Yes,
Yes,
sir.
So there you were dealing with the power of 2 and power of 3. So those were in
Yes.
the yeah, sorry, those were positive exponents which we were dealing with. You will be dealing with negative exponents also in this chapter. Getting it? Okay.
Yes,
So
sir.
suppose you had a number in this form, minus a raised to the power n. Okay. So minus
Hmm.
a here could be any number. It could be either odd, it could be even also, right?
Yes.
So
yes,
suppose,
sir.
let's take a case here. Okay. So suppose, guys, I take a number 5. Okay. And here I am taking as, let's say, 2. A here is 5, n is 2. And put it in
Yes.
this one. So it is minus 5 raised to the power 2. That gives you 25 now.
Sir,
25.
yes, sir.
Okay.
Yes, sir.
And then again, let's take another number, guys. In this case, let's take a as, keep the same number 5. Okay. Now here,
Yes.
let's take n to be 3, right?
So it will be a negative number.
Exactly. Getting it? What here?
Yes, sir.
Minus 5 raised to the power 3, that is minus 125. So what do we conclude from here, guys? That when the power, when the value of n is odd, or when the value of n is even, if the value
Yes.
of n is even, we are getting a positive
Even
value, no?
number. Positive. Yes.
Positive number, right? Or if you were having, if you were placing an odd number, then we were getting a negative number. In which case, in numbers which are like this, minus a,
The even.
Even.
no, minus a, minus a. right? So if you have an expression like minus a raised to the power n, so the number, the resultant value will be basically depending upon n. If n, whether n is odd or whether n is even here, that will
Yes.
determine whether the number will be positive or whether the number will be negative. Getting it?
Yes, sir.
Yes, sir.
Okay, so we may conclude from here. So we may conclude here minus a raised to the power n will be equal to either a raised to the power n or either minus a raised to the power n. When it will be positive one, when n is even,
Even, yes.
and
Yes,
it will
sir.
be a negative value when
Positive,
n is
odd.
odd. So both of you will remember this. Okay.
Yes.
Okay, I want you guys to solve one question. Okay.
Yes, sir.
So I am giving a number minus 3 raised to the power 2. Okay, do tell me what would be the answer. Will it be a positive or negative?
A
Without
positive.
without doing the actual calculation.
It's a positive.
Positive, right? Okay.
Yes.
It's a 9.
Okay. Minus 6 to the power 9. Just tell the value of the integer, whether it be a positive or negative.
It's a negative.
Negative.
Negative, obviously, no need to do the calculation in order to find the sign, right? Okay. So in this chapter now, we will be dealing with exponents of rational numbers. Getting it now?
Yes, sir.
Not integers, especially we will be dealing with
Rational
rational
numbers.
numbers. Okay. Also, few more important things you guys know to remember here. Suppose a number is in the form like this, a raised to the power n equals to 1. I
So
am
it will
having
be
an
0.
expression, yeah, equals to 1. When the
Hmm.
number will be equal to 1, the condition applied is that the power's value should be equal to 0. So I basically means that if I have a number, if the base is 5 here and the exponent is 0 here, so 5 raised to the 0 basically will give me 1. Or whether I have 6 raised to the 0, it will be 1. Getting it?
Yes.
Yes,
That
sir.
is the first thing. Okay. Then secondly, 1 raised to the power n equals to 1. What does it mean? Where n is any integer. So if I am having 1 raised to the power n equals to 1, it simply means whether you square root, whether you cube it, or whether you raise it
Yes,
to the
sir.
power of 4, it will still remain 1. That
Yes,
is
sir.
also correct. Then the third point, that what does it says? That if I am having a negative value minus 1 raised to the power n, it will be equal to 1 if the value of n is an even number, right?
Yes.
Yes.
Okay, just give me a minute. Let me intro Ahmed as well. Ahmed is waiting. Yes, Ahmed, how are you? Yeah. Walling stop. I'm having a bad throat today. So the third point, which I said, guys, here, that minus 1 raised to the power n will be equal to 1 when n is an even integer. The same
Even.
thing the moments ago I discussed here.
Yes.
It is somewhat similar to it. The only difference is that you are having a value 1 here. We are talking in
Yes, sir.
context of 1. Okay.
Yes.
So when n is even, what about the value we are getting is minus 1? It will be when n is odd, right?
Yes.
Okay. So the fourth thing. So Ahmed, you have joined a little bit late. Let me quickly summarize whatever we have discussed in the chapter. We have already started the chapter exponents, right now. Exponents and powers. So previously you must have studied about squares, cubes, is- getting it. So that is what the chapter we will be talking about here. So if you have a number 3 raised to the power 5, it will have two parts. One will be the base, another one will be the exponent. So this number 3 here is the base and the power to which it has been raised, it is called as its exponent. Then comes the question, what is the need to study the exponent? The need to study the exponents was because if you are having larger numbers, for example, the mass of Earth and Uranus have been given. Look at the numbers, how big they are. And then again, look at these numbers here. The distance between the Uranus and Sun, that is this much. Distance between Saturn and Sun, that is this much. So we will not be very, it will be a very difficult task to read them, to understand them, to write them and compare them. So that's why we have got exponent. So you are having this number, you can simply write it as 10 raised to the power 12. Hope so far it's clear.
Yes, sir.
Right now we are talking about powers with negative exponents. Getting it now?
Yes, sir.
Okay, so here we are dealing with numbers like this. This is what we were discussing. So if an is equal to 1, it basically means that the value of n must have been 0. Because earlier many times I have told you guys that if 5 is raised to the power 0, it will be simply 1. The whole value will be reduced to 1. Yeah. And then look closely, Ahmed here. If I have a number 1, no matter if I raise to 2, to 3, to 4, it will still remain 1 now. Like 1 multiplied 1 is 1, 1 multiplied 3 times is still 1, right now. And then again this, if I have minus 1, if I multiply it 2 times, that will become a plus 1. Now if I were to multiply it 3 times, then it will become minus 1, right now. So that is what here it is being said, that if you were to multiply it for even times, for 2 times, for 4 times, for 6 times, you get a positive value of 1. Now if you were to multiply it for 3 times, 5 times, 7 times, you were getting a negative value. Hope the basics are clear.
Yes, it is.
Yes. Now via the help of this table, you can visualize this. Visualize the powers and exponents. Getting it now, guys?
Yes, sir.
Okay, nothing too technical in this. So you are having one bubble here, 2 bubbles here, then 3 bubbles here. Consider that this yellow dots you are seeing here are as bubbles, right?
Yes.
Okay, so it is quite easy to see 1 bubble or 2 bubble or 3 bubble, 4 or 5, right now. But if you were to
Yes.
increase the number of bubbles, it becomes difficult, right?
Yes.
So
Yeah.
5 raised to the power of 5. So we can't count them easily. That's why we can simply represent as 5 raised to the 5, right now.
Yes.
Okay. Now then let's talk about how you expand a rational number using powers. Okay.
Yes.
So any given rational number, as I told you guys earlier, that exponents, the chapter exponent, in this class we will be studying in relation to rational numbers especially,
Yes, sir.
right? That is number in the form of a upon b where b is not equal to 0. So far you had
Yes.
talked about 2 squared, 3 square. Now we'll be talking about 1 upon 2 whole square, 5 upon 3 whole square or whole cube, like this, right?
Yes, sir.
And then we will be having rational numbers where the power will be negative in some cases, right now.
Yes.
Okay. Okay, so here you are having this number. It's a number is in decimal form. If you were to expand it, we all have been you all have been studying about expansion of numbers in childhood, right?
Yes, sir.
So 1204.65, 1204.65. If you were to expand it, you can expand it like this: 1000 plus 200 plus 4. Let me write it over here if it's not clear. Plus 0.6 plus 0.05. Yeah, no need to
Yes.
explain. Do I need to explain what we did here?
No, sir.
It is quite clear. Yes, Ahmed, Arhan, Arham. So
Yes.
No, sir.
Yes, sir.
1000 can be simply written as 10 raised to the power 3 now.
Yes.
Yes, sir.
Okay, how else can we write 200? Can we not write it like this? 2 into 100. Yeah, 4 can
Yes.
be written
Sir,
as
2 square.
2 square,
Hmm.
right now. Or what
Yes.
about 0.6?
0.03 square. 0.3 square.
No, no, zero, not 0.3 square,
No.
not 0.3 square. You
Okay,
will
then
write
put on
it like you will write it like this. It will be weighted the value in, yeah, 0.6 here or 0.05 here. So you will be writing it as like this, 6 into 10 raised to the power minus 1.
-1.
Okay, or plus 0.05, you will be writing it as 5 into 10 raised to the power
-2.
minus 2. Let
Yes.
me explain to you why we are doing it like this. 0.6 equals to 6 into 10 raised to the power minus 1. Because in few moments, I will be telling you that if you have got a, yeah, if you have got a number like 10 raised to the power minus 1, it can be written as 1 upon 10.
Yes.
Okay, just understand it. I will explain it later on. Okay, so 0.6 is same as 6 upon 10 here. And 6 upon 10 here, we know it is same as 0.6. Yeah.
Yes, sir.
Okay, Ahmed.
Yes, sir.
So here we did basically the expansion of the number, like this 10 cube plus 2 into 10 raised to the power 2. 100 can be written like this. Yeah.
Yes.
Plus 2 square plus 6 into 10 raised to the power minus 1 plus
1.
5 into 10 raised to the power minus 2. So
2.
that is how you expand a given number using powers. Getting it?
Yes.
Now, suppose I give you another number, like a number a upon b. Okay, this is a rational number, and I keep on multiplying them
Yes.
up to, let's say, n times. How many times? I don't know. Okay, so it will mean what? You are multiplying the
So it will
numerator.
be a.
Yeah, you will be multiplying the numerator also with n times,
Yes. And the denominator.
and the denominator also.
Yes. A upon
Isn't
b
it,
equals
Ahmed
to
Arhan?
n
Yeah,
whole square.
So it will be a by b is to the power n whole.
very good, very good, guys. So we can write it as a raised to the power n upon b
Also.
raised to the power n. Okay,
Yes. We
so
can also write
also,
whole square, right?
exactly, I'm writing the next one. It can further be written as, since both numerator and denominator has got the same exponent, we can write them like this also. Ahmed
Yes.
Arhan, Arham, is it clear to three of you?
Yes, sir.
Yes.
Yeah. Okay. So suppose I have given you a number here, 2 upon 3 raised to the power 4. Expand it. And how would you guys write it? Whoever,
2 raised to the
whoever,
power 4 upon 3 raised to the power 4.
very good. 2 raised to the power 4 upon 3 raised to the power 4. And then,
2 into 2 into 2 into 2.
exactly,
Yes.
right. So this is what it means basically. Okay.
Yes.
All right. Now I will be giving you guys few questions. You need to solve it.
Yes, sir.
Yes, Ahmed, are you able to connect? We have joined a little bit late, but still
Yes,
you will
sir.
be able to connect with the topics. Yeah.
Yes, sir. I can connect with the topics.
Yeah, good. So 3 upon 5 raised to the power 3. All you guys are required to solve it separately and answer in the chat box.
Yes, sir.
Okay.
So we have to give the
So what
answer.
do we have to do in this?
You have to evaluate them, solve them, find the final answer.
Okay.
Yes.
Like this one here.
So find the value or simplify them.
Simply simplify them, like just how I have written like this, 2 upon 3 raised to the power 4
Okay,
equals
sir.
to 16 upon 81.
Okay, sir.
and you are required to send it on the ID, not on this one ID, this one, not my full name. Okay.
Yes, sir.
Yes, Arhan, that is correct. Very good. Arham, Ahmed, have you guys sent the first one?
Yes, I am sending. I've sent
Okay.
one.
Okay, that is also correct. Arhan, the second one which you have sent, that is wrong. Arham, second one, that is correct. The answer of second one, Arhan, that is wrong.
So I've sent all the three.
Yeah, third one, that is also correct. Arham, very good. Okay. Ahmed, I haven't received from you.
Oh, yes, I'm trying to solve.
Okay. So the first one, basically 3 multiplied 3 times, that's what we are going to do.
Yes, sir.
Let me further simplify it. So it will be basically 3 raised to the power 3 upon 5 raised to the power 3. Why? Because from here,
It's whole square. Yes.
right? So 3 multiplied 3 times upon 5
27.
multiplied 5 times. Getting it?
27 upon 125.
Exactly. 27 upon 125. Then the second one, same thing, you will be doing it with this one also,
Yes.
right? So that is 81 upon 256.
256.
Okay. Someone sent 246. That is wrong, right?
Sir, I mistakenly typed 4.
Okay, no issue,
I
no
was
issue.
meant to type 5. I
Okay.
sent the third one answer.
Third one. No, third one will be minus 32
22 upon
upon
243.
243.
Yes.
Getting it? So minus 2 raised to the power 5 upon 3 raised to the power 5. That is minus 32 and that is 243.
243.
Okay.
Okay.
Okay. Is it clear, Ahmed?
Okay, so yes, it is clear now.
Okay. Just have to multiply it. Hope that is clear. Right. Now let's talk about the negative integral exponent of a rational number. What does it mean? If you guys like, you can take the screenshot of this page.
Done, sir.
Okay.
Wait, I'm taking it.
Oh, guys, do one more thing now. In a more formal way, it's better like just after each class now, prepare the notes. Basically, write down the things which we have discussed in the class.
Okay,
Okay.
sir.
So, for example, in today's class, what are the things we have talked? Or basically, if you were to start the chapter, first you will be writing about exponents and powers, and draw this diagram basically here. Basically, write this and denote which one, which is called as base, which is called as exponent. Indicate that.
Yes, sir.
Okay. and then you will be writing this definition, the definition which I gave you guys. Where is
Yes.
it? Get me, get that. Yeah, the numbers that are very difficult to read, write, understand, and compare. To make these numbers easy to read, easy to write, compare, and understand, we use exponents. Getting it? Write
Yes,
these
sir.
things and then write the rules. What rules? These rules. The first rule is this one. Okay, so you will write this rule and then you will write this rule. These two things you will be writing in your notebook. Okay,
Yes.
no need to draw this table here. Then again you will take write this example also in your copy. Getting it?
Yes, sir.
So these things you will be writing down, and then at last, not at last, then next, the third thing you will be writing down will be this. Writing, getting it? Okay.
Yes, sir.
So this will help you guys in revising the topics. Whenever there is test, it will help you guys to revise the topics. Okay, shall we move on then?
Yes, sir.
Yes, sir.
Okay. Now let's talk about negative integral exponent of a rational number. Rational number. Moments ago, I told you guys, if you have got a number like 10 raised to the power minus 1, it can be written as 1 upon 10. Yeah.
Yes, sir.
So here you have a whose exponent is negative. Now you are writing it like this, 1 upon a, and the exponent became positive here. Okay.
Yes, sir.
So that was in context of a whole number. Now you have got a rational number. So suppose you are having numbers like this, a upon b raised to the power minus n. So you can write it like this. Simply, in order to convert this exponent from negative to positive, what you can do, you will simply reverse the order of the digits. You will simply write b upon a, and the exponent will automatically become a positive one. Are you guys getting it what
Yes.
I'm trying to say?
Yes, sir.
Yes.
Ahmed, Arhan,
Yes.
good. So for example, if you have a number 2 upon 3 and I have raised it to the power of minus 3, that is exponent is minus 3. So in order to solve this question, find out our answer, what we will simply do, we will simply reverse the order of the numerator and denominator. Bring the numerator to
Yes, sir.
denominator and denominator to numerator, right? So it will be 3 upon
Yes.
Yes,
2.
sir.
Then the power will become
3.
positive. Very good.
Yes, sir.
So it is 3 cube upon 2 cube. That is 27 upon 8.
Yes, sir.
So this thing is clear. So
Yeah.
that
Yes,
will
sir.
be the fourth topic in your note. Okay, and in bracket you can write this also. Right. Okay, let's solve few questions. So question 1 is 2 upon 3 minus 4. Question number 2 is 4 raised to the power minus 2. Third question is 1 upon 6 raised to the power minus 2. Three questions are there. Okay, solve this question. How we have to solve this to all three of you, it is clear now?
Yes, sir.
Okay. Ahmed, is it clear?
Yes, it is now.
Okay. Arhan, don't write the sentence. Just find the final answer. Just like I have found out in the given example here. Okay, Arhan.
Okay, sir.
Yeah. Although the statement is also correct here. Okay, very good.
Sir, I have sent all the three.
The second one is wrong. Arham, the answer of the
Yes, sir.
second one which you have sent, that is wrong.
Okay.
Okay, while the rest two is correct. And Arhan, yes, first one that is correct. No, the second one is again wrong.
Sir, is it? I'm sending. Is this correct?
Okay. Ahmed, I'm waiting for your answer. Yes, Arham,
Yes.
that is correct. It is quite simple, Ahmed. Just look at the above example. The same thing you have to do it here as well. Just copy the same method. It will become very easy. Yes, Arham Arhan, second one's answer is correct. Good.
Okay, sir.
Okay. Yeah, the last one, that is correct. Good, good, Arhan. Okay. Ahmed, did you got the answer?
I'm sorry for myself.
Okay.
So
Okay.
shall do I have to send the answer?
Yes. Okay. So try to solve the questions. The method is clear to you, know.
Yes, sir.
Okay, I will be explaining the second one. Okay. So it is 4 raised to the power minus 2. Is it not in this form? A raised to the power minus n. So it will
Yes.
become 1 upon a. That is 1 upon
16.
4. And the powers
Yes.
value will
Four square.
be positive. So 1 square upon 4 square, that is 1 upon 16.
16.
Good. In the third one, that was also same, easy. So you have to reverse
Yes.
the
Yes.
order. So it will be 6 upon 1 raised to the power 2 now. Simply 36, right?
Yes.
Okay. Okay. Shall we move ahead then? Any confusions?
No, sir.
Okay.
No, sir.
Now, next thing we will be talking about is the law of exponents. There are different laws of exponents, right?
Yes, sir.
Okay.
Yes,
So
sir.
what are the different laws? Hmm? For example, now let's suppose that you have a upon b. Let a be any rational number, and m and n be any integers. So what we have done here, हमने क्या किया है? We have assumed a upon b as any rational number and m and n as any integer. Let's play
Yes,
with
sir.
these values with this number here. So let's do one thing. If I were to multiply a upon b and a upon b, but I am raising them to different powers. The first rational number, let's say I raised it to the integer m here. The next one I have put integer n over here. Getting it
We
here?
add
What I've done here.
exponents.
So what is the thing which we are observing here? Ahmed, Arhan, Arham, the bases are common now. A upon
Yes.
b and
Yeah.
a upon b here.
And the powers are different.
Exactly. So bases are same, but the power are different. So in this case, how
The
the
power
questions
will
are
get
solved?
plus.
Exactly. The powers will be added. It will be
Yes, sir.
m plus n. Right now?
Yes, sir.
Okay. So for
Yes,
example,
sir.
if I have a number 3 upon 5 raised to the power 2 multiplied 6 upon let's say 8 raised to the power n over here. Sorry, 3 over here, right? So
Yes, sir.
no, we have to take the same number. No, we have taken a different number.
Yes, sir.
3 upon 5 raised to the power 3. So it will be basically added 2 plus 3,
5.
right? 3 upon 5 raised to the power 5 and 3 raised to
Yes.
the power 5 upon 5 raised to the power 5. This is how you are supposed to solve such questions. Getting it now?
Yes, sir.
So the
Yes,
first
sir.
one is clear. So take the
Yes, sir.
screenshot of this one.
Sir, taken.
Done? Okay.
Yes, sir.
Ahmed, you also? Arhan?
Yes, sir.
Yes, sir.
Oh, okay. No confusion in this one. No, please do tell me if there's any confusion.
No, sir.
No, sir.
Okay, guys. Now let's look at another law. Now, let's say we have got the basis a upon b and sorry, rational number and then the same rational number. Okay, remember you had the rational number a and b and the integers m and n. We have assumed that, right? Now,
Yes, sir.
suppose you are dividing them and then you put the exponents m and n over their head. Now, what can we do here? What will happen here? Here, the same bases are in division with each other and their powers are different. So you will
Yes.
take the common base and you will subtract the exponents.
Yes, sir.
Yes, sir.
Getting it? So for example, just take any example, let's say 3 upon 5. Okay. So you raise it to 2 and then again divide it with the same base 3 upon 5 and raise it to the power 1. So it will be simply 3 upon 5, 2 minus 1. Exponents are getting subtracted over here. So it is simply 3 upon 5 raised to the power 1. Getting it? So that is the
Yes.
second law of exponent. Then move on to third law. So suppose you had the rational number a upon b, you are raising it to the power m first. Okay.
Okay.
And then again you raise it next time but to the power n here.
Sir,
Yes.
m will get multiplied by n.
Exactly.
Yes.
So keeping the base same, you will multiply the exponents. With an example, let's try to understand this one also. For example, like you have 2 raised to the power 3, 2, and then again raised to the power, let's say 4, and then again raised to the power 6. So what we were doing here, all those exponents were getting multiplied here, right?
Yes, sir.
Okay, so no matter if you had m and or let's say if you had one more exponent, you just need to keep multiplying them. Okay, so let's solve one more question here. So 5 upon 6 raised to the power 5 raised to the power 3 raised to the power 9. How do we write it?
5 3s are 15. 15 multiplied by 9, which is 125. No, 135. 5
No,
upon
no.
6 is the
5
135
upon
whole square.
5 upon 6, then simply multiply the powers.
Yes, sir.
Okay, is
It
that
will
what
be
you
Yes.
said?
100.
Yeah. So whatever values come, you have to
135.
do it like this. It will be
So
135.
135.
Very good. Right. Okay, so guys, take the screenshot of this page. Okay, and if you have any confusion, please do not hesitate, any one of you. Okay, get your confusions clear in the class only, right now. And there's no
Yes, sir.
shame if you fail to understand anything. There's no shame in it, right? Okay,
Yes,
shall
sir.
I clear the screen then?
Yes, sir.
Okay. Now, so far we have studied how many? 3 laws of exponents. Now,
Yes.
Now you are having now you are having another rational number c upon d, let's say, and the same integers m and n. Okay, so a upon b multiplied c upon d, getting it here.
Yes, sir.
And here what I am doing, I have raised them to the power of n over here.
Yes.
Both of them are multiplication and raised them to the power of n. So I can write it like this: a upon b raised to the power c multiplied c upon d raised to the power, and that is quite simply, that is simple here.
Yes,
Yes, sir.
Getting it? Or you
Yes,
can
sir.
also write it like this: a upon b upon c upon d raised to the power n. Right, all those things are same here. So for example, to take an example here, 2 upon 3, right,
Yes, sir.
divided 4 upon 5 raised to the power n. So you can write it like this: 2 upon 3 raised to the power n upon 4 upon 5 raised to the power n. Getting it?
Yes, sir.
Okay. Solve one question on this. Right. So I am giving a exam question here. 1 upon 3 multiplied 5 upon 11 raised to the power, let's say 3 here. Solve this one as per the rule. Okay.
So absent.
Arham, there's a slight mistake in this.
Okay.
Okay. So you have got this now: 1 upon 3 raised to the power 3 here. Again, 5 upon 11 raised to the power 3. Okay. So what value you will be getting? 1 upon 27 multiplied 125 and 1331. Yeah.
Oh, yes.
Further
Oh,
you will
yeah.
be further you will multiply it, and then you will be getting your answers simply. Whatever 27 multiplied 1331 comes. Right?
Yes.
Okay. For convenience, just study up to this one also. Okay. The next one we will include in next law.
Yes, sir.
Getting it? So the fourth law of exponent is basically, if you have got two rational numbers a upon b and c upon d, but they are being multiplied and have been raised to the common exponent, it can be written like this. Getting it?
Yes, sir.
Okay. Or the fifth one, let's say if you were to have a upon b raised to the power n divided by c upon d. Both of them are being divided here, and let's raise to the power of n. So how can we write them? It will again be a upon b raised to the power n divided
Yes.
c upon
yes,
d
sir.
raised to the power n, right?
Yes. N
So
minus N will be.
exactly, so that is simply easy. Okay, and you
Yes,
guys are
sir.
already aware that if you have got a number like this, numbers which are in division with each other, you can reverse the order. Do you guys know? Like 1 upon 2 divided by 5 upon 3. It can be written as 1 upon 2 multiplied 3 upon 5.
Yes, sir.
Yeah. Ahmed and Arham, you guys are aware of
Yes,
this, no?
sir.
Yeah. So same thing can be done here as well. 1 a raised to the power n upon b raised to the power n. You will simply reverse the order while solving it. It will become more convenient because multiplication is simpler than division in many
Division.
cases,
Yes, sir.
right? Okay, shall we move ahead then?
Yes, sir.
Take this,
Yes, sir.
take the screenshot of this one.
Sir, take me.
Okay, now suppose you are having a rational number a upon b raised to the power minus n. Okay, it can be written as b upon a raised to the power n, where n is a positive integer.
Yes, sir.
I guess we discussed this moments ago, the same thing.
Yes, sir.
Yeah. So suppose you are having, let's say 1 upon 2 raised to the power minus 3, it will be 2 raised to the power 3, like this. Okay, that is pretty simple. Now one
Yes,
more.
sir.
If you are having a rational number like a upon b raised to the power 0, the value is going to be what?
1.
Obviously 1. Okay,
Yes.
same as integers. If you have got 5 raised to the power 0, it was 1, minus 3 raised to the power 0, it was 1. Same as the case was with integers also. Okay,
Yeah.
Yes, sir.
so that these are basically 6 laws of exponents which we have discussed, right?
Yes, sir.
Let me quickly revise them for you. Take the screenshot of this one also.
Sir, done.
Okay, and you guys have to write them in your copy.
Yes.
Okay, so quickly I'm writing all the laws here. So the first law was a upon b. Who will tell me the first law?
Sir,
Yeah, add
the
the
I'm writing
A
I'm writing
upon
the
B
first part only.
by
Oh,
uh,
okay, I will be writing the first part only. The second part you guys will be completing and I will be calling names. Okay.
Yes, sir.
okay, sir.
Okay, Ahmed, tell the first one.
Sir, he's not in the meet, I guess.
He's not here.
No.
Okay, then you tell.
The first law, the second, first, right? We
First one.
add the exponents and we take the a upon b as common.
Common base. Arhan, second one.
So we minus the power and we take A upon B as common.
Exactly. Okay. Now, Arham, you tell me if you have an expression like this, then what do?
We multiply the powers.
We multiply the powers. Very good.
Powers.
Okay. Then the next one. Arhan.
So we will take so we will since the power is getting multiplied by the
On whole of the value.
Yes, sir. So we can take A upon B by n multiplied by C upon D by n.
Raised to the power n. C upon D raised to the power n. And further it can be written like this also. Right?
Yes,
Yes.
sir.
Good. Okay. And the next one, Arham.
We reciprocal the base and then the negative power becomes the positive power.
Very good. Okay, last one, Arhan.
So the whole number will be 1.
1, exactly. There was one more, like if they are being divided, the same thing will be done in that case also. Right?
Yes.
Yes, sir.
Okay, same thing. Okay. Okay, so that is basically in the chapter. These were basically the laws of the exponents. Now we will be solving different types of questions, right? Okay,
Yes, sir.
so let's solve few questions. If you like, take the screenshot of this one also. It's basically summary of all the laws of exponents.
Sir, can you I can't see the sixth law.
Sixth one. Okay, I'm writing
Yes.
over here. A upon b raised to the power 0 equals to 1.
Yes, sir, done.
Done. Okay, now let's solve few questions. Evaluate. The first one is 1 upon 3 raised to the power minus 4. Second one is 4 upon 7 multiplied 4 upon 7. Here let's raise it to 5 and let's raise the another one to minus 3. The third one, 3 upon 2 raised to the power minus 3 multiplied 3 upon 2 raised to the power minus 2. Solve these three questions.
Okay, sir.
Okay, Ran, the first one is correct. While the second one, let me check for the second one. I'm afraid the second one is wrong. Is it 4 upon 7? No?
Yes, sir.
Okay, okay, then it's correct.
Sir, I've sent the second one.
Yeah.
The third one.
Third one, okay, I'm checking. That is correct. Very good. Very good. All three answers are correct. Arham, are you solving it?
Yes, sir, I'm just sending. I've sent
Okay,
the
okay.
first.
Yeah. Correct. Both of you have sent 81. Just tell me the value.
Of second one,
Yeah, second one.
it's 1024 upon 16,007 multiplied by 343 upon 64.
4 upon 7, you have raised it to the power of 2.
5.
You have to, no, why 5? See, the
Which
bases
one?
are same now. Second one.
Yes.
Second one, you see, you have to simply add the powers now. It will be like this now. 4 upon 7, since the base are same. So you have